Okay, and class, remember, I'm going to, it will be better if you have two terminals, which I proposed last time, so that you can run this in the real time. Okay, so let's explore MPLAB X. Okay, we just click MPLAB X. And MPLAB X is written using Java NetBeans. It takes some time to load. Okay. So you can start your MPLAB X now, all of you. And before that, you need the Lab1 companion material. Here, the Lab1 companion material. I hope you have downloaded all this. Okay, you can get this, in our Weibo or the note section. We have a lot of files here. Okay, from a class material. So please download this, the Lab1 companion material. Okay, let's open the practical manual. Okay, we're going to use this, till the end of the semester. Okay, please, is it the same procedure? You're asked to install the following MPLAB X, okay? And just ignore tentatively, just ignore this because we are not going to use STM32, okay? 2 years ago, your senior are using that, okay? So you just ignore this, we ignore the virtual driver STM link. Okay, the CubeMX, actually is the IDE for STM32. For those who are using STM32, you need this actually. We just forget about this number 4. Okay, so ignore the installation at MDK IDE. Skip step 3 and step 4. Okay, so this is what we are going to do over here. Okay, so actually I already prepared a video 1 to video 5, and it's based on the old MPLAB version 8.92. I created this 4 or 5 years ago actually. If you want this video, you just give me a thumbs up. I'm not sure whether you're going to watch this or not, because this video 1 to 5, they do not have voice. That is the very first time I'm doing my live recording. Okay, this is what we're going to do today. Okay, these are the pre-lab. So my dear, can you just remove your control? I accidentally pressed, you're taking over my control now. Can you remove that? Okay, let's coming back to this. Okay, this is what we're going to do today. Okay, we are using PIC24, PIC18 F4550 instead of 4520. Okay, we write a code, you know, to toggle port B and port D. Okay, so using C programming. Okay, I will guide you step by step. And these are our mission today. Mission 1, identify all the header file. We identify the disassembly listing. We explore the watch window. We try to do all the different type of debugging using a simulator. Okay, and so on. Okay, we explore all these, you know, mission 1 to mission 10. Okay, these are the pre-lab. Okay, so let's begin. Okay, so before we start, again, you know, please ensure that you have all this companion material. Okay, so okay, let's begin. Okay, so it's very simple. First, we create the new project. Okay, so normally I just put it as a standalone project. Next. So now I'm trying to use PIC18. Okay, so we are using PIC18 F4550. Okay, are you following? So and of course I'm using a simulator. Okay. Let's say, for example, you have PIC3. If you have a PIC4 PIC3 or PIC4 install, you can choose the related things over here, related debugging tools over here. But however, we do not have all this. That's the reason we choose simulator.
Sir.
Yeah. Yes.
You are not sharing your screen.
Oh, because just now you take over the control. Yeah. Where is it? Hold on. Just now, sorry. Just now somebody, you know, take over control. You know, that's why I press the give control. You know, create this problem. Okay, let's begin everything again. Okay. So, okay. Can you see? Can you see my screen? Just give me a thumbs up. You can see my screen. Can you see my screen? Okay. Okay, great. Okay. Let's begin. So first of all, make sure that you have all this material with you. Okay. All this, because you're going to use this later. Okay. Secondly, you need this. This is what we're going to do today. The mission 1 until mission 10. We'll begin by using PIC18 F4550, an 8-bit microcontroller. Okay, because you are familiar with this microcontroller before we move to 16-bit or 32-bit microcontroller. Okay. So class, remember today I just teach you the tools. Okay, you will learn the MPLAB X. You know. Okay, let's begin. Switch on. Start your MPLAB X. Okay, this is how it looks like. Okay, so then we create a project. File, new project. We select a standalone project. Next. And there are so many family over here. Okay, so the one we are using today is an advanced 8-bit MCU, which is a PIC18 F4550. You can directly type PIC18 F4550. Okay. There's a tool here. If you have debugging tools like PIC3, PIC4, okay, you may select, you know, PIC3 or PIC4 underneath, okay, or ICD4. But however, we do not have all this, okay. But the tools, the debugging tools that we're going to use is just a simulator. Next, okay. So, and make sure that you have installed the XC8 C compiler, and we select an XC8 C compiler instead of assembly code. Okay, we are not using assembly. Okay, next. Okay, then you can simply create a directory. Let's say I browse, I create my directory. Okay, let's see. Let's say pre-lab. Okay, so this is up to you. Okay, this is your folder. Okay, anywhere. Okay, you better put as some your preferred folder so that it's easy for you to trace all this information. Okay, so the project name I just put Bling. Okay, so set this as main project. Is it okay so far? Let me check. So everything is okay, going smoothly. So then I just press finished. It takes some time because that's one of the reasons I don't like MPLAB. Okay, so yes, Wei Hen got some problem. We are using XC8. The compiler is XC8. Okay, Wei Hen, the compiler is XC8. Is it okay? Please say okay. No option for you to choose. Okay, have you installed XC8 or not? And XC16? You need to install, the C compiler. Make sure you install the XC8 C compiler and XC16 C compiler. Okay, have you? Okay, Kai Jin, you just need to type, don't copy and paste. Yeah, copy and paste, then it works. Okay, we make it. Okay, let's do like this. Okay, first of all, have all of you install XC8 and XC16? Yeah, the link. Okay, now how many of you encounter problem, of choosing the C compiler? Okay, let's do like this. I repeat the process. I close the project. I repeat the process again. Okay, so I repeat. Okay, so file, new project. Okay, and one thing you need to be noted while installing MPLAB X IDE, XC8 and XC16. Please ensure that all these antivirus software, like I'm using Sun New Link, like your McAfee, all these things, please disable it first, because during the time of installing, there's something is coming out, might block you, will block the installation. This will automatically create a lot of problem later, when you're running the MPLAB X. That's what I encountered yesterday while I'm installing the latest version 5.40. So please ensure that you disable all this. Okay. Okay. So I repeat the process again. So file, new project, standalone project, and this the device family will appear, and I'm using PIC24 FJ6 PIC18 F4550. Okay, and I'm using simulator. So let me know who having problem, with this. Let me check. Wei hand. Wei hand. Wei hand use. Is it okay? Okay. No problem so far. Okay, then you press next. Is this disappear? I'm selecting the XC8 compiler. So make sure the C compiler have been installed, in your terminal. Is it Wei hand okay? No C compiler option for me to choose. Wei hand, have you installed the C compiler? Okay, Wei hand, I think you just please reinstall the C compiler and see what happened. Strange. Okay, so I continue. It's very straightforward later. Okay, next. Okay, so I create my Blink 2. Okay, so finished. Okay, so, and you can see that on your left side. Okay, here is the information of your project, and these are the dashboard. Okay, so class, few things you need to do now. First, you need to go to the tool, option, embedded. Okay, over here we got a debug startup. At your terminal, it should show run. Am I right? If yes, give me a thumbs up. So what does it mean? Means that when you run the debug, your program is automatically running. Okay, so normally I don't like this. Okay, I prefer it hot at main. Means when I run the debug, when I press the debug later, the debugging process will automatically stop at the main and let me to control the running process. Okay, it's up to you. You can disable it. You can change later. Okay, to see what are the differences, between hot at man and hot at run, and as well as hot at reset vector. Okay, so normally I prefer hot at man, means it stop at the main when I press the debug button over here. Okay. Okay. So then we go to the source file. There's no source file over here. So we need to create our C source file. So we just put file, new file, and I'm looking for C programming. I just put source file. Next. Okay, just type your C program name, give him a name, blink.c. Okay, just finish. Blink.c will be created. Finish. So automatically, this page will appear, blink.c. Okay. So you can start writing your program now. Okay. So let's recap. First, make sure that you install MPLAB X, CalUVision, and Proteus, okay, for this pre-lab section. And we're going to use these three as well in the lab 1 next week. Okay. We start with PIC 18. Okay, we start with PIC 18. So first we start with PIC 18 F4550. This is a 8-bit microcontroller. Okay. So what we're going to do today is we try to have this. Okay. This is normally used, when you do testing. Okay. So the testing to test whether this microcontroller is working or not instead of whether the port is functioning. So sometimes when you purchase microcontroller from internet, we don't know whether it's working or not. Sometimes their port, let's say port A, port B, is 8-bit. So we are not sure whether all this port is alive or not. Okay. So today we want to do a testing. Okay, we try to simulate, write a program to simulate whether this port is functioning or not. Okay, so what we're going to do is this. It's very simple. Okay, so let's move this away. Okay, hold on. Okay. Today we are trying to connect everything to port D. Sorry. Port D. Okay. And port B. With LED. Okay, we give them a blink, 055, then put a delay, then 0AA, and let the process repeat. Okay, is it all right? It's okay. Give me a thumbs up. It's a very simple testing process. Any questions? It's a very simple. Okay. So, okay. Now let's go back to the program. So before we are looking into more details, Wei Han, is it working? Wei Han, is your terminal working? Okay, please message, if you have encountered problem now, still installing Wei Han, we are waiting for you. Okay, while waiting, let's do something very interesting. So no matter whatever microcontroller we are using, we need an header file. Okay, in microchip, the header file is universalized. Okay, what do you mean by universalized? So this means that whenever you choose PIC 18 F4550 and you type this header file, okay, this header file will automatically direct you, to all the versions of PIC 18 microchip and link it to PIC 18 F4550. So you're not sure what is that? Okay, very simple. Let's try it. Right click, navigate, go to the declaration. You can see this coming out. Okay, this page. And you see PIC 18.h. Right click, navigate, go to declaration, okay, and you see htc.h, okay, you can see this page, okay, okay. So then again, we look for PIC18 chip select.h, right click, navigate, go to the declaration and definition, and this page will appear. Okay, so this page basically show you all the PIC18 family controller, 18F1220. Okay, so we try to look for PIC18F4550. The gray color means is disabled because we are using PIC18F4550. So that's the reason the gray color is. I mean, this line, these two line, you know, is marked in gray. So let's look at PIC18F4550. If you're lazy to scroll down, you can search. Okay, you can search, you can find. Okay, PIC18F4550. Okay. You see or not? Only this, you know, 18F4550. Only this is marked in orange color. Okay, so this means PIC18F4550 header library is active. Oh, wait, and you install exit in the wrong hard drive. Okay. Okay, we are waiting for you. Yeah, class, while waiting for Wayhand, okay, so we just navigate again, go to this declaration. So this is a PIC18F4550. This page is very important. Okay. So kindly just scroll down and see what is that. Okay. Okay. In the meantime, we can come back to the Lab 1 companion material, go to microchip, and click the PIC18F4550 datasheet. Okay. And class, you're allowed to interrupt. You know, while I'm, even though, and you can talk to me anytime, and you can interrupt by sending me message. Okay, probably if sending through message is a bit delay, probably you can just switch on your mic and ask for help. Okay, is it all right? I hope everyone is following. So this is PIC18F4550 datasheet. So you can see we got 28 pin, 40 and 44 pin. It's a high performance flash, enhanced flash USB microcontroller with nanowatt technology. Means it's a very low power devices. Okay. So this is a very powerful and very popular microcontroller. So PIC-Kit 3 is constructed using this microcontroller. PIC18F4550. Okay, as you know that when you come to microcontroller, there are a lot of special function register, like here. It's not shown here. Okay, there's a lot of special function register, like say for example T0 cont, T1 cont. Okay, so and this special function register is typed with their own address. Okay, so but with the header file over here, it helps you, to identify which function register that you're going to use later. Let's say, for example, like just now I told you that we are going to use port D. So how am I going to write port D? So if you're not sure, you can always search from here. Let's say from here I can type, okay, port D. Okay, You can see from here. So he already defined the port D as port D. So this means that you can directly use port D, you know, in your blink.c. I will show you later. Sometimes, you know, you can't remember all these special function register. Let's say again, let's say for example, in the data sheet, they show you T1 con. So how I'm going to type? Can I just type T1 con like that? So if you're not sure, just copy and paste this, copy, and come back to our program. Okay, so you can check, is it really we can use T1 con? Yes, you can. You already defined T1 con as T1 con. Okay, so, and moreover, inside T1 con, they got so many example, come back, inside T1 con, there's so many individual bits, 8 bits, TMR1 on, TMR1 CS. Can I just use TMR1 on, you know, in our C program? Okay. If you're not sure, always come back over here. Let's say T1 con is defined as a structure. So T1 con itself, you can directly use TMR1 on as an individual bit. So this means that it's an unsigned. It declare T1 con bits, you know, inside got a TMR1 on as an individual bit. So is it clear, class? Okay. So that's the reason, you know, if you're not sure what special function register to be used, what individual bits to be used, you can always go to the data sheet and copy and paste over here to ensure is it the correct bits, you know, to be used. Okay. Is it okay so far, class? If yes, give me a thumbs up and you may ask questions. And are you following? Okay, so it's very simple. Okay, let's come back to our blink.c. Okay, let's go back to the port D example. Okay, so as you can see from here, port D, let's go back to the data sheet. Sorry, class, I'm jumping here and there. Let's come back to the data sheet. Okay, let's look at the pin diagram. So this is a big F4550. Where is port D? You can see from the screen, port D is over. Where is port D? So RD, you see or not? Okay, so port D, you know, is shared with other, I mean, port D can be an input-output port. It also share with other, it also can have other functions like for example, RD7 is a SPP7 or P1D. Okay. Okay. So no worry. Let's come back to the MPLAB header file. So this means that port D itself can have RD, can be an input-output port, can be other special function as well as PP7. So, okay, you can directly use this individual bit, you know, okay, for example, as an LED. So RD0 equal to 1. So this means that RD0 output 1. Okay, is it clear, class? Okay. And I believe that you learn from microcontroller, microprocessor. Normally, when we send things to the output, we send to the latch. We read the input-output port. We output to the latch. Am I right? Input through the port, output to the latch. Input from the I mean, if you get input, let's say it's a switch, it should be go into the input port, okay, and latch the output. Is it clear, class? So when you learn in what you learn in microcontroller, microprocessor, when you want to send something out, you know, we normally send it to the latch instead of the input-output port. Means not to RD0, but LAT0. This one. The latch. Normally, what we say is we latch the output, we read the input. We read the input port, we latch the LAT0. This latch is tied with the input output port. Is it clear, class? You can, okay, Nick, yeah, okay. How to search keyword again, edit, you can find over here, and or Control F, okay? So class, I repeat, so to make it clearer, okay? So class, this is LED. Let's say we have something like this. Okay, this is an output. This is an input. Okay, when you want to send something to the output, you need to go into the latch first before it's going out. When we read the input port. Let's say RD0 is equal. If RD0 equal to 1, then we're doing something. If RD0 equal to 0, we're doing something. So we read from the port. Okay, when latch. Okay, want to light up the LED, we should send 1 here. So let's say this is a RD1, so the RD1 is equal to 1. Okay, sorry, not RD1, it's a LAT1 is equal to 1. So instead of using RD1, okay? So the reason of this, we'll discuss further when it comes to chapter 3. Okay, and actually, you should know this, in your microcontroller, microprocessor. Class, so far, is it okay? Is it okay, class? We are. If yes, give me a thumbs up again. I know that it's very messy just now. Is it okay, everyone? Okay. Okay, very good. Okay, thanks, Kai Chin, Wei Lun, Yao, Yok Kim. Okay, no problem. So how about others? Other got big problem, is it? How about other? Yeah, Jun Chuan, are you sure? Or others already went to toilet or what? Okay. So class, if you want to go to toilet, just send me a message, just say, oh, I need some time. Still downloading MP-Lab, my dear Seng Chen. How come? Okay, is everyone okay? I want to move forward. Okay, Seng Chen, you can watch the video again. Is it recorded? I think yes. Yes, is it recorded? Yeah, it's recorded. Okay, let's continue. Okay, class. So in order to have a good documentation, let's say, for example, just like I told you, I want to connect a series of LED to port D and series of LED to port B. Okay, am I right? Okay, so so it's very bad if you write like this. Example, class. Okay, normally when you type things, we need to void main. Okay, and then beginning and end. Okay, this is the thing we should type. Okay, so let's say, for example, if you type like this, LATD equal to 0x55. it's not very very good, isn't it? Because how do you know what is LATD? So for a good C programming writer, you should give a define. Let's say I want LED 1, is part under LATD. Okay, so this is more organized. So probably give a comment. Port D, connected to series of LEDs. Okay, we give him a definition. So this is what we call a good documentation. Okay, then probably we also have we define. Okay, LED 2 to LATB. Okay, so means port B is connected, to series of LEDs. Okay, so it's more organized. Okay, and since just now we talked about latch, let's play around with switch as well. Okay, so let's say also we put in a switch. Okay, define a switch. Okay, as an individual bits. Okay, as an individual bit. RA0. Okay, class. When you see RA0, okay, means let's put like this. Okay, when we look at individual bits, let's say we put dot A bits. You press dot. It already tell you that all the port A bits, it's easy for you to link with. Let's say we link with RA0. Just put RA0. Okay. Okay, so this is more organized. Plus, if you're confused, always come back, to this port PIC18F4550, to see, okay, how they assign port bits, port bits they assign for a single bit, all these things is all over here. Okay. Okay, let's begin our program. Okay, still remember when you learn microcontroller, another thing is input output, correct? Because for microchip we talk about directions, okay, and the directions is controlled by the tris A, bits. Example, if you've forgotten, let's say for example TRISA. Oh my God, I shouldn't change this. This is a tris bit. Still remember tris bit? Tris bit means it's an individual bit, whether that particular bit is a input or output. Okay, is it all right? Okay, let's come back. Okay, now our tris B, it should be an output, and our tris D is an output. Okay. So I can't access the PIC18F4550 header file. Okay, Junkit, if you're not able to access the PIC18F4550 header file, so this means that during installation, you are not installed at the proposed directory. Doesn't matter, you can try to do this, okay? Okay, you go to your, okay, Junkit, just have a look, not, okay? You go to this C file, program file. Let's find where is a PIC18F4550. Let's check. Is it here? I can't remember whether it's in x86 or not. Okay. Okay, we found this. Okay, so right click, property. Junkit, you copy this link. copy, copy, okay, then you go back to it's for Junkit only, okay, you just say include, okay, double quote, right click, stroke, okay, and you forgot, if you forgot a file name, go back, come back over here, copy this, take 18F4550H, okay, when you right click this, navigate, it's the same thing will come out. Is it okay? Junkit? You know, the reason you can't use xc.h to navigate to this directory because during installation, you change, you know, your directory from C to D drive. I'm not sure, or because C drives you do not have enough space, you install to other drive or other directory, you know. Okay, am I right, Junkit? So far, okay, class. I know that all of you are already very tired. Everything must be installed in C. Yes, Ying Hao. Preferably, because this is due to microchip itself. They are, you know, when the person who write the MPLAB X, you know, using Java, you know, NetBeans, all these things, they're predefined the location in C drive. Okay. Yeah, in C. C should be in C. Everything in C directory. Okay. Okay, let's move on. Okay. So you also can have a tries A0 is an input. Okay, let's have a look. So when something display black color means something is not right. Example, you see, give me a note. Okay, something is not right. Okay, so you always, let's say I also forgotten, you know, what is a correct way of put tries A0. Then I come back over here. I can tries A0 should be like this. Copy. Okay. Let's say whether it's working or not. So I'm not sure this definition, but those days I'm always using this. Let's say whether it works or not. Okay, we try and we have to try later. Okay, we try it up and down and see whether it's really working or not. Okay. Then tentatively we try later during debugging. Okay. So, okay, class. Is it okay? So then let's come back to go back to the data sheets. Okay, RD7 is over here, and RB is over here. Is still okay. RB is still okay. Okay, let's check. RA0. Okay, RA0. Okay, RA0. They're sharing analog digital pin as well as RA0. Okay, whether it's an input output pin or whether it's an analog or digital pin, analog ADC for ADC purpose. Okay, let's say other RD is here, RD is here. Okay, 3. Okay. So class, one thing you need to be noticed is this. Let's look at the analog digital converter just for a while. Okay, this is for, where's the analog digital converter? ADC. Okay, come to ADC here. This is ADC. Okay. Class, by default, class, when you look at ADCON 1, by default, when you press reset, this pin is 0. This pin is 0. Okay. PCFG012. Okay. By default, when you press reset, this pin is all 0. You see 1 here, all 0. So when all 0, this means that this pin is as an analog pin. Now we are not dealing with analog pin, we are dealing with digital. So it's a good practice. If you're dealing everything in digital, you should set everything to 1 instead of 0. You put it at, by default is 1 is the analog pin. So this means that when you didn't notice this, you didn't change, and you connect your push button, always thought that the push button, the microcontroller always thought that the push button itself is an analog input. Instead, it's not. Okay, so that's why it's a good practice. You know, if you're doing everything in digital, set this 3 pin to high, to 1. Okay, so come back to this. So this is a practice. It's a good practice. Okay, but however, try port B and port D. We don't even. It's not a problem at all. So so it's a good practice. Okay, so I just say ADCON 1 is equal to 0x0f. Okay, just for safety purpose, because we are using RA0 as a digital pin, so that's why we set everything into digital. So again, I repeat. Okay, ADCON 1. Just remember those days, if you're accidentally using connect AN0, as your switch, that's why those days you keep on saying, why it's not working? Why it's not working? Because by default, ADCON 1 is 0. It's analog pin. It's not digital pin. Okay. So is it clear, class? Okay. Okay. Low car pin and Ang Xiang Long. Okay. Okay. Let's say the pin is not appear. Okay. Let's come back to this. Okay. So when Xiang Long, when you type this, press a dot. This table appear. No. Okay. So then, tentatively, you define this. Let's see what happened later. Okay. Tentatively, you try to do this. Okay. Okay. Is everyone okay? Then we write our program. While 1. Okay. Remember, last time it's just equivalent to short jump again. You keep on looping the program. Okay, while 1. Okay, then what should we do? LED 1 is equivalent to 0x55. LED 2 is equal to 0x55. Okay. So you give them a delay. So we repeat this. AA. It's very simple and very straightforward, and give them another delay. Okay. Okay. So of course the delay function is not there. We need to write our delay function. It's very straightforward class. It's nothing. Okay. Delay unsigned long. Let's say give it a very long delay, or you can put unsigned integer. Okay. So for I equal to 0, I start with 0. If I less than, let's say 10,000, okay, then I plus plus. Okay. So of course we need to the header definition. Come back here. Before the main, you put this void main delay over here. Okay, everything gone. Is it typo? Unsigned, UNSIG, unsigned. Okay, we miss out this. Okay. Let me enlarge this screen so they can see clearly. So this one is equal. So now you already create 55AA. Not minus, equal. It's a very simple design over here. Okay, so far okay. No, it's not minus, it's equal. Yes, yeah. Yes, any question?
What does the 0x55 represent?
Pardon?
The 0x55 and 0xAA.
Yes.
Why we put that value?
Why we put that value? Okay, it's toggling. Okay, let's say, okay, let's come back to this one. Please. Okay, doesn't matter. Yeah. Okay, why we put that value? Okay, let's hold on. I'm not familiar with this. Okay, let's put this. Let's say this is RD0 until RD7, and we got sequence of LED here. Okay, so we connect this to the LED. Okay, so 1 0 1 0 1 0 1 0 is AA, 0 1 0 1 0 1 0 1. So we put a delay here, means it keep on blinking. I just want to check whether the port is really alive or not. So this means that it's all blinking and on and off means that this port is working. Just for testing purpose. Normally we always use this, for testing purpose. You don't need to connect the LED. Actually, you can use a multimeter, put a long delay, hook on the multimeter and check that all the pin is functioning or not. Okay, or you hook on the oscilloscope. It should be up, down, up, down, up, down. LED, you don't need multimeter to check. You connect to the sequence of LED. Okay, so you blink, keep on blinking, RD0, RD7 blinking, and same as for port RDA, the port A, you keep on blinking. So to ensure that particular microcontroller for that particular section of ports are functioning. Is it okay? Is it clear? For those who are having problem of this port A0, I'm not sure. Okay, just copy and paste this. Try and see whether this is working or not. Probably you can't link to the right header file. Okay. Are you sure you typed correctly? It's a port, PORTA, small case BITS.I0. Okay, is everything working? Seems like it's not easy, to conduct lab sections through. Okay, there's one interesting thing, Actually, I can control your terminal. If you got problem, I can go over to your terminal and change things, for you. Okay, you understand what I mean or not? Like just now, young gentleman take over the control. I haven't tried this before. You share your screen. I think I can control your screen. I can control all your information. I can control your terminal. If you allow me to do so, so is everyone okay? Is everyone now very boring or what? I'm not sure. Yes, Kai-Chin, yes. So, okay, yeah, Kai-Chin, anything? I think it's better switch on the mic and talk to me, it's easy, I try. Okay, pick 18450, yeah, include pick 18450, yeah, you can go ahead, okay. Pick 18450.h, okay. So, class, why some of you can't, of xc.h is due to the time that you're installing your MPLAB X. You change the directory, you don't want to install in x86, you change the directory, you install in D drive, you install in F drive, that's why, the microchip itself is not so intelligent, to link to this particular PIC18F4550H, okay? You know why? Because let's look at xc.h, you link it to here, the PIC select. The PIC chip select, you link it to this, okay? Sometimes they couldn't locate this, for you, okay? So either you just directly copy this, or you guide him, guide him to this particular directory, okay? Is it okay? But of course, you're doing like this a bit lengthy, you have to identify where is this, where is the location of this PIC18F4550, okay? So as I told you just now, xc.h is a universal linkage to the respective microcontroller that you choose. Let's say I choose PIC184550, I just need to type xc.h. If I choose PIC24, I just type xc.h as well. Okay, this two is linked. Okay, is it all right? Okay, since we are doing this here, since we're gonna switch, let's make something more interesting. Okay, 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 add-con is done here, round 1. Okay, means that the program is running main. While the switch is equal to 1, I do 0 first. Is 0, I do nothing. When 1 is coming out, okay, remember, class always remember, This is a simulator. Simulator do not know, the simulator does not know how your circuit is constructed. This is very important. Okay. So by default, in programming, in simulation, is always a negative logic. Okay, it's a negative logic. Okay, what I mean is this, class. Listen carefully. So remember just now, if I want to connect this circuit, pull to VCC, the input is always high. When I press this button, the input is go low. When it goes low, then I perform some action. Am I right? Okay. So you can't do this, in the simulator. The simulator is negative logic. It always assume this pin is low, is 0. Okay. Is it all right? Do you got what I mean or not, class? Okay. If yes, give me a thumbs up or type ask. Okay. Xc.h not complete. What do you mean, Kai Chin? Okay. Okay, I repeat. Okay. Remember, simulator, he don't know how the hardware is being connected. For example, if the connection is like this, I put it to high, all right? By right, when I press low, then we perform some action, correct or not? Like example, if I connect the hardware, I should write like this. While switch equal to 1, I do nothing, correct or not? When I press the switch, then I do something. Am I right? But remember, program MPLAB do not know how you connect your circuit. By default, it's a negative logic. So that's why for testing purpose, for simulation purpose, you should put it to negative logic is 0. Okay, it's not 1. But you go to hardware, you should put this at 1. I hope you got what I mean. Okay, let's it's 10 to 10:30 already. Let's compile this. Hope there's no error. Okay, before compilation, remember things that you need to noted, things that you should not, a bit of setting, a bit of understanding of how this thing is working. Okay, class. This is, let's look at the screen. This device is here, okay. Yeah. Cancel first, okay. All this information, debug tool is simulator, okay. Okay, let's briefly introduce these things, class. Listen carefully, You go to tool. Don't do it now, because yesterday when I tried this, my whole system is just blank, okay. I'm not sure whether it's MPLAB version 5.40 got problem or what. But however, 2 years ago, I already make a video. I will give the video to all of you, okay, to have a look, okay. So, but all this thing is make your life easy only. Okay, let's click the plugin. So these are all the available plugin you can install, to your MPLAB X. As I told you just now, yesterday when I tried to install few very interesting plugin, my whole MPLAB just go blank. Not blank. All these icon here become very, very tiny, very, very miniature. I will show you after this. I'm sure it happened again. So few things that you should note that if you want to use real-time operating system to look at how all the tasks is running, you can install this. Okay, free RTOS. But as I told you earlier, I'm not going to use FreeRTOS over here. Instead, I'm using the Micro COS2. FreeRTOS, we use it on my ESP32. Okay. Second things that you should know is the MP-lab code configurator. Okay, MP-lab code configurator makes your life easy. Okay, but it's for those who are very good, in programming. Then you go ahead with code configurator. If you're not so good in programming or just a beginner, I think you should not use code configurator. Code configurator basically make your life easy, shortcut. Okay, example, if you install code configurator, the one icon here, MCC, will appear. I got the video, don't worry. So you click that MCC, the whole PIC 18 F4550 IC will appear. You just click, they got a top-down menu for you. Click, timer 0, how many settings should I do? I want to use UART, port A, I want to use input output port. You just click. Next. He create all the initialization file for you. You don't need to type at all. Okay, so this means that you do not need to type this, icon 1 0x 0f. You just click. It automatically generate all this library for you. Make your life easy. Okay, so you don't need to look at the datasheet anymore. You just rely on the MCC. But of course, that's why I say, if you already know how to do the configuration, how to do the initialization, then you can go ahead with code configurator. If you are still don't know, still a beginner or looking at this datasheet, I still prefer you type. Okay, so you can try later. Then another things that we should look is the Proteus. Where is my Proteus? Proteus VSM Viewer. When you click Proteus VSM Viewer, is tied with this MP-lab. When you do debugging, you can do a real-time debugging using the MP-lab, as well as the Proteus will become alive. Okay. Okay, no worry. I also have a recording on this. Okay, yesterday I tried the whole night. When I installed the Proteus VSM Viewer, something strange happened. I'm not sure whether I'm using the Proteus XXX copy or whether the MP-lab X, this version got problem. For your information, MP-lab always got problem. Okay. Okay. So this is a brief introduction to all of you first. Is it okay, class? If okay, give me a thumbs up. I want everyone is okay. Is it clear? Everyone, just 3, only 4, only G-Sync, others are lost in action, is it? Okay, I don't know. Okay. Let me know who is still encountering problem. If later not okay, can PM you. Sheng Chen, what is your problem just now? Cannot install. Yes, you can PM me, Sheng Chen. We can have an individual chat as well, no problem. Kai Chin installing, why so long? Yeah, all these problems will occur, I tell you that. Okay. Okay, never mind. This is recorded. You can always play back. Okay. Let's move on. Okay. Then the next thing I want to say is this. You press this banner here. Project property. Okay. There's a lot of things over here. Okay. When you come out, you can see this XC8. All right. Just for information, yesterday when I installed the Proteus Viewer just now, the plugin, this page is disappear. When this page is disappear, I cannot link it to my Proteus. I also don't know why. Okay, but never mind, that's not important. Okay, let's look at the general. So this is the information about inclusion. Okay, view. Okay. Simulator. Okay, class. This is a simulator. This is the place where you put your instruction frequency. Okay. This is place where you put your instruction frequency. I got a question for all of you. Can anyone tell me what is instruction frequency? Okay, you can Google. I don't know if fast enough. So those who can explain to me what is the difference between oscillator frequency and instruction frequency, I give you some bonus point. Okay, put in the messenger. Now the first 3 person, yeah, just have some fun. What is the difference between FOSC and SCYC? You should know this, because you will learn a lot from a microcontroller and microprocessor. Why means you're Googling, don't Google. Okay. Google take time, you see. Why so slow? Okay. Hit the jackpot, Ying Hao. Yes, very good. Okay. Okay, very good, Ying Hao. Okay. So oscillator, let's say for example, just for your information, let's put this. Okay, let's put change the color, green. Okay. Pick 18. Let's say your oscillation frequency is 10 megahertz. The FCYC is 10 megahertz divided by 4. Okay. If you are using PIC 24, if the FOSC is 10 megahertz, the FCYC is 10 megahertz divided by 2. Okay. If you are using a bit out of the box, if you are using 8ML89S8252, this is an MCS 61 microcontroller. The FCYC is 10 megahertz. If you're using 10 megahertz, it's divided by 12. Okay, just for your information. Okay. Okay. So we come back over here. So this is if you 1 megahertz. So this means what? The oscillation frequency, the crystal frequency, whether using internal or external, it should be 4 megahertz divided by 4 become 1. So this is an internal RC oscillator for backup. Okay, we'll come to that later. We'll not. Okay. Is it clear or not, class? Okay, let's check. Is it clear? Is it okay? Yes. Open what?
Project properties window.
Project properties. This one. This one is it?
Oh yeah.
Yeah.
Where you open this?
Where I'm open this? Take a spanner. Can you see a spanner here? Do you have this? Do you have this?
Oh yeah.
Can you see a spanner?
Oh okay. That's right.
Click this. Yeah.
Okay.
Okay. So okay, I move on. So these are the things. So simulator. This is the SCYC. So this is very important. You want to check the timer, all these things, whether it's correct or not. Okay. So then we move on. So even the oscillator frequency, there's a lot of information here. Like I just click. The very popular one is this. This is to enable the UART. You want to output something through your UART. UART means that universal asynchronous receiver transmitter for the RS232 transmit receive line. If you want to display some output onto your screen from testing data. Okay, so okay, so loading. Okay, this loading class, look at here carefully. Are you listening? Loading here, you can have these load symbols when programming or building for production. And class, listen carefully. when you compile this file, this C programming will automatically convert into an assembly code. Okay, from the assembly code, they will same time they will create the hex code for you. Okay, how intelligent is XC8? Okay, the answer is the current copy that you have now is not intelligent at all because it's free. There's no code optimization. You got what I mean or not? Means you type your C programming, they will convert into assembly code for you. And during the conversion, there's no optimization. That's the reason your code is very lengthy. Okay. Then from there, they will convert into the hex code. And this hex code, eventually you go into your microcontroller. Okay. What we call as a firmware. Is it clear? Okay. So, but in order to display the assembly code, how they do the conversion, you can always click this. Slow process. Okay lah, my computer is 6 core. Okay, it doesn't matter. I'm not sure, but I believe that you have also no problem. This is not slow process. Okay, for me it's perfectly all right. Okay, you can always click this. You want to see the assembly code. Okay, clear. Let's move on. Okay, there are some more things here. I'm not going in details. And here, this one, XC8 global option. Okay, very important. So C99 is the latest standard, of C programming. So just fix it. The output file format. The output file format, please put it at a COFF, because in order to have a in order to have a full debugging concept in your Proteus, we need the COFF file. Okay, so that's why you put it COFF. COFF is a debugging file, the debugging file that you should load into your Proteus later. I will show you. Okay, just put COFF lah. An XC compiler. I'm going very slow. Forget about it. Optimization, nothing. You can't do anything because you are not. Hey, where is it? Where is mine? Okay, is everything okay? Why I can't find that? Okay. Okay, COFF. So if okay, then okay lah. Okay. Okay. So when you compile this code, sure got a lot of warning. Let's compile and see. It's a bit slow. See, they see or not? They see a lot of warning. It's working, but a lot of warning. Okay. So he said missing configuration setting. Okay. Let's go back to the data sheet. In the data sheets, where is this? Let me do some searching. I don't have. Okay. Page. Which page is it? Page 286. Page 286. 289 meh? 286 ma? Okay. Look at page 286. Okay. So PIC 18F4550 got a lot of configuration register. So headache. 1, 2, 3, 4. Bah, 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 bah. Okay, you want to set all these things. It's very, very tedious. Am I right? Can I ask, do you set this in during your microcontroller, microprocessor? Shit, come on, type something. Yes or no? Do you set this? No? Do you set this? If no, means sometime when you do your assignment, sometimes you keep on reset, you know, you don't know why also. Why suddenly when I run this for long, after some time, it's keep on resetting. You see? That's why I feel a bit strange. You say no. Okay, it doesn't matter. If you got time, you go through all these things. Okay, but of course, I'm not going through this because we are not targeting on PIC 18. I'm targeting on PIC 18 because you're familiar, you know, with this chip. Okay, let's come back to this. Luckily, at least PIC 18 give you a bit of comfortable life. Close this first. You just go to the window. Go to the window. Where is it? Go to the window and go to the target memory view. Window target memory view and go to the configuration bits. Click here. Can you see? I can I enlarge this? Cannot or can? Okay. So this one is for you to do all the setting if you're not sure what is that. Okay, option 1. Okay, 1. Okay. Okay, I don't care about this. Okay, FOSC. Okay, let's say I'm since this thing I'm using the internal. If I'm using the internal, okay, yeah, I'm using the internal. Let's say I click this. Oh, what is HOSC? Okay, just check out. Or internal oscillator. HS oscillator used by USB. Okay, I'm using the internal oscillator. Okay, I put internal oscillator and off, and something on. You have to be careful lah. But brown out reset. Brown out reset means that you set such that if your microcontroller drop at less than the 3 volt, he auto reset. You understand what I mean or not? The brown out reset. Brown reset means enable hardware. Okay, so the minimum setting is 2.05. You can set the value over here. Okay, when you run your microcontroller in hardware, the microcontroller suddenly the voltage drop below 3 volt or something, then he auto reset your system. Okay, so it's up to you want to on or not, because now it's just a simulator. He don't create any big impact. Okay, let's say for example I off it. When you off it, it gives you an exclamation mark. You change it. The most important things I want to talk about is a watchdog timer. So, who don't know watchdog timer? Who don't know what is watchdog timer? Give me, send me a message. You say don't know, or DK. Or no? Forgot. Okay, watchdog timer is like this. You know, dog. Okay, let's say for example, I start my watchdog timer here. Example, you got software like example. We'll go more details when it comes to chapter 3. I start my watchdog timer here. So I expected when I come to here, it should be 2 took 1 millisecond, example, from here to here is 1 millisecond. If it exceeded 1 millisecond, it should be reset. The system should be reset. You got what I mean or not? So he will reset it automatically. So this means that if you on this watchdog timer, okay, and you got a prescaler here, so this means that if you're, let's say for example, your FCYC just now is 1 megahertz. So 1 megahertz is 1 microsecond. 1 megahertz is 1, okay. Then it's a 32768 microsecond. So after this 326768 microsecond, he will auto reset itself. The system will auto reset itself. You understand what I mean or not? So therefore, for testing purpose, normally we will switch it off. Watchdog timer is very good, you know, to prevent the system hang, you know. Let's say you run your program, so then your program is hang. If hanging, you cannot continue. Correct or not? So better, the system will automatically reset itself. Okay. So watchdog timer, one of the usage of watchdog timer is to prevent the system hang, you know, in the middle of your program probably due to hardware failure, I don't know, due to some electromagnetic interference or etc. Okay, is it clear? Okay, so when you come to simulator, if you put it off on, probably when you run for keep on looping this while one keep on looping after some time he keep on reset, it keep on reset of itself. Okay, just for your information. Okay. So other thing I'm not going through in details. You want, this is for code protection, or no, for your EEPROM. Okay. So I think basically that's all. So once done, I can generate the source code. Generate. Okay. I just copy this. And just put up here before the xc.h, or you can create your own library, include config.h, okay, and store inside. So I put it over here. Now a bit messy lah. So you can save this. You know, you can create a new header file, or you save it in that particular header file as well. Okay. So done. The configuration bit done, and then I believe that now when we run again, all the error, all the warning will be disappear. Okay, there's one more warning. What is that? Okay, he just said that this is to you keep on looping. You know, that's why he tell you the warning. Okay, it doesn't matter. This keep on looping. The program won't run, okay, because of this keep on looping. Okay. Okay, now it's a time to debug this program. Okay, let me close all this. Okay, so this is the debugging. Okay, class, if you have a Pickit tree that you can press this button to download, you know, the hex code into this particular thing. Okay, and class, before we moving on, I want to stretch one more thing here. Okay, so still remember just now we have, let's look at this because a lot of students don't care about what is going on here. Okay, so class, look at this memory. So this is the amount of data memory I'm used up. Okay, this is the amount of program memory I'm used up. 128 here, 4 here. Okay, so in future when you write your own design, less is better because you don't utilize a lot of the program memory. Okay. Okay, one more thing I want to noted. Just go through this so long. Okay, this one, class. This one. Let's look at this. We have to go to the directory. Okay, and want to dig out this bling.x.production.hgx, the hex code. Okay, the hex code. Okay, let's go to the directory. The directory just where you created just now. Here I'm created as C user pre-lab, correct or not? So I'm going to that particular directory now. Okay, just now it's just Bling. According to date is this one. Okay, so it's over here. The hex code. The COF file is over here. This is the hex code. Can you find the hex code? Give me a thumbs up. You're able to find the hex code. Can you find the hex code? Yeah, can you find the hex code? Give me a thumbs up. Or you just directly copy this directory, you know, see here, this one. Or you just search lah, everything come to, let's say you come to this, bring, just type everything .hdx. Okay, it will come up for you now. This hdx, yeah, and this hdx, okay, this hdx, okay. Okay, I copy this out. I just put it over here. Okay, if you can open with my WordPad. I don't know why my computer and I need to convert to text file first. Okay, you don't need to do what I did. You just open with WordPad. You can see this. So this is a hex code. This is the one who go into your target controller. If you got PickIt 3 or PickIt 4, you always download this into your microcontroller. Am I right or not? Give me a thumbs up. Why no thumbs up one? Ayo, so difficult. I don't know whether you are doing the right things or not. Okay. Why this hex code is so important? I will let you know during in chapter 2. Are you ready? Okay, if ready, who cannot find this hex code? Who not able to locate this hex code? Me, Wei Hen again. Okay, Wei Hen, here, my dear. You come back here. When you compile just now, you got this, correct or not? So the hex code basically is at this one at this directory. You know, at this directory. You go to this, the directory. I mean, where you create your project just now, the same folder. Okay, the same folder. You go to the same folder, this folder. Okay, this folder. Okay, it's a Bling 2x. Bling 2x. Okay, dist default production. The hex code is over here. Probably you already hide the extension. If you hide extension, go to where? Go to the property. Not property. Where is it? View. view file name extension. Don't disable it, enable it. Okay. This one. A lot of you disable this, then you can't see. Yo, which one? But they are type lah. You can look at the type. It's hex code. Okay. Just double click and open with WordPad. For me, I just copy out and put it over here and double click. This is it. Okay, everyone can locate this. Yes, I give you some time. Okay, let's rest for a while. I also talk a lot. Let's rest for 5 minutes. 3 minutes. 3 minutes. Let's rest for 3 minutes. Okay, let's rest for 3 minutes. And whereas I go and don't look at me lah. I'm very messy today. Okay, let me. Okay, chat with me if you got any problem. I'm still here. I'm downloading the attendance first. What happened? That's for 2 minutes. Okay, let's say any. Yes, the entire is recorded. Everything is recorded. No worry. Okay, it's all recorded. Okay, but of course, just now the process is a bit lengthy, so I don't know whether you can search or not. Okay, don't have this file compile fail. Xiangli, where are you, Xiangli? Can you show me your screen? Share your screen. Let me have a look. It's very difficult. Xiangli, can you share your screen? Sharing screen is here. I check for you. Compile error. Compile fail means some typo error. Or Xiangli, I just send you this document file. You know the type. Okay. I send you this. Okay, no worry. Hold on. I send you this .c file. Okay. I send you this. I put this thing in. Okay, save your time. This .c file I put into the Microsoft Teams if you don't want to share. So it's good to know for you to share a screen so that I can have a look. Okay, Jiangli, hold on. How did I share this? How do I do this? I go back to here, files. Okay, where is it? Why no file? No file. Okay, how come? Oh yeah, Jiangli, just hold on. Last material. I just drag this .c bling.c over here so that you can directly use it. Okay, save your time. Hey, I cannot drop. How come? I cannot. Okay. So guys, I share my bling.c just now. You can directly use it. Okay, Jiangli, you try to just probably some typo error. Just remove yours, remove from the project and add the file. You know, the file that I gave to you. Okay, or overwrite it. Okay. So from my side, there's no problem. Can we rest for 2 more minutes? Can you pause the recording? You can't pause the recording. Yeah, Xingyang, any questions? Why there's one? What is this? Okay, never mind, Jiangni. Okay, you try to use the .c file that I given to that I just uploaded just now. No worry, recorded. I can't find. Jinghao, can you locate your hex code? Why I don't have the hex code? How can it be? Yichuan, this is a pre-lab. The next sections we directly start with PIC 24. Of course, the process will more or less is the same. Wei Hen, can you locate the hex code? Jinghao, can you locate the hex code? Give me a thumbs up if you're able to locate the hex code. Wei Hen and Jinghao? No? Okay, hold on. I think you need to press something. Give me a minute. General file inclusion. Angel. Means you can't find this. And how many of you not able to locate the hex code? This one, hex code. Okay, never mind. I think I need to press something. Hold on. Click here. Simulator. Code cover option. Where is it? Reset. Hold on. Let me debug for you guys. When okay, Xiangli, yes. Will the configuration be changed based on the setting? Yeah, based on the setting, yes. But it wouldn't affect things during simulation. Loading simulator. Where is the place? I think need to press something, to generate hex code then. Something called hex code library. Okay, I just want to check with all of you. When you compile, do they have any errors? And do you see this hex code? Or have you go to the directory that the directory, just search for hex code. Is it there? No statement in hex code. Hold on. I think must have been some setting that you didn't press. Where is the setting? It must be somewhere here. You can have a look. Try to locate it. General, it shouldn't be here. File, not here. Config simulator. Let me check. Oh, come on. Lot simple. Not impossible, by right the hex code will be generated. Okay, okay, Xiangli, you should declare your function just now. Okay, I already, okay, class, how many of you able to locate the hex code? Give me a thumbs up. How come, why you all got, some don't have? What is the reason? Wei Han, why yours one is production file, but ours one is debug file? Wei Han, what do you mean? Directory? No, I mean, this is automatically generated. Okay, Wei Han, like this. Okay, okay, like this. Okay, tentatively we are not going to use this hex code. You know, I mean, you only use it when you want to download this into the target processor because you are not doing the hardware. Okay, so therefore it's not very important at the moment. Okay, Wei Han is like this. Why don't you do like this, Wei Han? Those who are got problem of this getting hex code, you know, directory problem. Okay, I suggest you to do this. Remove, uninstall the program, uninstall using this software. Where is it? Revo uninstall, full uninstall, even everything, you know, even the registry, you know, all the link, all the file directory that link with MPLAB will fully uninstall through the Revo uninstall power. Okay, so uninstall everything XC8, XC16. Okay, reinstall again by disable all the antivirus. Okay, don't hook on internet, you won't get virus. Okay, disable all the antivirus and all the Trojan remover, all these third-party software, you know, that might affect, you know, the installation process. Reinstall all this again and try again. Okay, is it okay, class? Is it okay, Wei Han? I also don't know why. I mean, I can't, you know, Wei Han, can you another solution? You share your screen to me. Or maybe you can do it later. Okay, so when after 12 o'clock we can have an individual discussion. We see what is going on. Those who have got problem, you can stay back. Okay, if you're worried that you share your screen. Okay, okay, let's move on. Let's move on. Everyone is back. If back, give me a thumbs up. Is everyone back? There's more things, you know. Okay, let's continue. Okay, class. Don't worry, we'll repeat this. Okay, okay, class. Let's look at the hex code. So these are the hex code. Something like this. This is how we divide it. Okay, let's pick one line. Let's pick this line. And so on. Okay, so remember, I hope you know what is the difference between little endian and big endian. If you don't know what is little endian or big endian, let me know. Why nobody responds? No, big endian means that the higher address store the higher byte. Lower address store the lower byte. Okay. Okay. Let's have a look. Okay. Before that, let's come back to the MPLAB X. After you have do the compilation, you go to Window. You go to debugging, output, disassembly listing. These are the hexa code. These are the assembly code that is generated by the XC compiler. Like for example, tries bit tries is equal to 1 in assembly code is a bit set flag. You know, this is how they do it. It's very lengthy because there's no optimization over here. Okay. Is it all right, class? Can you see this? Go to Window, debugging, output, disassembly listing file. This file only appear if you press this lot symbol when programming. Okay, for production slow process. Okay, can you see this? Okay, so let's have a look on this. Okay, let me clear this. Don't save. File, new, blank. Where's my pen? Okay, come back here. We use this. Okay, okay, class. It's very simple. Okay, so colon is indicate you go through this, you know, during the chapter 2. Colon means the beginning of the line. Beginning of the new line means colon. Okay. 0, 2 means that they got 2 data, you know, 1, 2. 0, 0, 0, 0. Like let's take this 10 means they got 10 data, which is started from the address 7F94. 0, 0 indicate is the beginning of the data. 0, 1 indicate the end of the data, end of the file. 0, 4 means it's the extended address. Okay, so I repeat. So ignore the 0, 4 first. So colon beginning of the new line. 10 means we got 10 data. This is hexa. 10 means 16 in decimal. Okay. And this data is starting as address 7FA4. 0, 0 indicate the beginning of data. So this means that 7FA4 contain 04, 7FA5 contain 22, 7FA6 contain 50, and so on. Okay, the total is 16 data over here. You can calculate, is it 16? Is it 16? Okay, and the last one is checksum. Checksum. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now, 10 means 16. Like 2. 1, 2. Clear? And the last one is the checksum. Checksum means that this is for error checking. You know checksum, checksum error. Add all these together, perform a second complement. Like for example, 0, 0, F is 0, 0, F is 0, 1. 0, 1 second complement is FF. I hope you know what is second complement is, which you learn in under the subject digital. Okay, so far, any questions? Let me check. Let me check through my phone. Any questions? Okay, wait, good. You can find the hex code. Hex code is generated when you compile, when you do the compile, when you do this compilation. Here, this one. You press compile, clean and build a project. The hex code will be automatically generated. Okay, and those who still got problem of compilation error, can you use my file? This file I already uploaded into the files here. Class material. This one. Use this blink.c. Probably during the time you typing just now, you got a lot of typo error. Okay, finally we can get all these things. Kaitin, what is your problem? COFS, yes, okay. Actually, this is doesn't matter on and off. It doesn't matter. But watch short timer, just make sure it's off. That's all. Okay. Okay. So everyone okay? Okay, I repeat the hex code again. Okay. Come back to this. It's easy. Okay. So first, we start with colon. Yeah. Okay, colon is indicate a new line. Okay, new line. Let's pick this. 10 means you got 10 data we store starting from the address 7FA4 means 7FA4 will contain 04 7FA5 contain 22 and so on. Okay, is it all right? 00 is indicate the beginning of the data storage. 01 means that end of the file, end of the data. Okay. 04 means that we are using the extended addressing mode. Okay, that's it only. I'm not going details on this. Okay. So finally, 0E is a checksum. Add all these things together. First complement plus 1. This is called a second complement. We got 0E. Means that add all these things together. 01, second complement is FE, plus 1 is FF. All right. Okay. So basically, where is this? Is here. You come back to here. You can see this. Okay, let me make this smaller. Let's say 7FA4 is 04. 7FA4, where is A4? You can find out. Well, let's simply, we choose 7FCA. CA is here. Zero E 00. Why 0E00? Because it's a little endian. 7FCA is a lower byte. You store 00. 7FCB is the upper byte, we store 0E. So this is a 7FCB. Okay or not? I type here. So 92 is a CA, CB, 4, wait, no, 4, sorry, not this one. Not this one. Is it this one? No. Sorry, C4, C5, C6, C7, C8, C9, CA is 00, low to low, high to high. So CB, okay, is 0E, it's here, 0E. So this means that this line actually is represented as move, okay, with the register at 0x00. Is it clear, class? If clear, give me a thumbs up. Why so quiet? You didn't get it? Only 3 means other don't even know, lost in the jungle. Okay, at least 4. I need 33. They got 33 of you over here today. Yes, lost. Oh dear, wait hand, don't worry. Okay, so class, I repeat. Okay, what is hex code? Okay, I repeat class slowly. Okay, each one I know. Okay, remember, this is an elective subject. This is an elective subject. You still got chance until next week. Oh, no, just joking. Okay, class, listen carefully. Okay, so whatever things you do, whether you are in micro, you're using Python, you're using whatever thing, you know, you need to download the firmware into your target controller. Okay, the thing go into a target controller actually is in a binary file. Okay, fine. The hex code you convert in the binary file. Okay, so if you're writing using C programming, they will convert into the assembly code for you. Okay, this assembly code, this like move, all these things, you can understand. The microcontroller don't understand. So that's why, therefore, actually is represented by a very unique hex code. Okay, so this sequence of hex code, you're going to convert in the binary and download into the target processor. Okay, so how the hex code format looks like, whether you like it or not like it, this is how it looks like. Okay, so remember, only 2 types only in this world. One is a Motorola standard, which is called S19 file, .S19 for Motorola those days. And another one is the HEX, is a hex code. It's an Intel proprietary standard. Okay, so most of the microcontroller, like microchip, like MCS51 family, like ESP32, all these things are using the hex code. Okay, it's hex code. So let's look at the 8-bit format of hex code. This is a PIC18. It's an 8-bit microcontroller. If you got PIC24, 16-bit microcontroller, the hex code will be a bit different. If you got PIC32, it may be a bit different. Why hex code is so important? Let's come to our chapter 2. I'll tell you why it's so important. Okay, but we need to identify how this hex code looks like. Okay, some technical things. Okay, so let's say, for example, this is the hex code. This is the one you're going to target processor. Let's pick a number. Okay, this is how it looks like. Colon means indicate a new line. See, every line got a new colon. Okay, 10 means that in this line, they got 10 data. 10 data in hexa means got 16 data. 16. Okay, starting from the address 7FC4 means 7FC4 will store 92, 7FC5 will store 80, 7FC6 will store 00, and so on. The total data stored until here is what? Is 16 location. Means 16 location, 16 data, because 10 is 16. Means 7FC4 will store until 7FD3. The last one is a D3. Definitely is D3. D3, 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 D3. Okay, D3. Okay, the total here is 16 locations. Okay, and the final byte here is a checksum. Checksum means that we add all these one byte, add all together and perform a second complement. Why Qing Ting want to control my things again? Okay, okay. So 0f. Okay, remember 0f is a checksum. You add everything together. You use a calculator, add all together. Second complement, you got 0f. Example: add all these things together. 0, 1, 0, 1. Second, first complement is what? Fe. Plus 1, ff is the second complement. Okay. Is it okay? So this is how this thing looks like. Now, for example, just now I'm choosing, which one I choose? I forgot already. CA, CB. Okay, CA. Okay, 7FCA content 0E00. 7FCA content 00. Why 00? Because it's a linked endian, low to low. CD is 0E, then CB is 0E. Two address ma. CC is 95. CC is 95 or not? CC is 95. Okay, is it clear? So we are so slow. Is it clear? If clear, give me a thumbs up. I'm very tired already. Okay, very good. Okay. Okay. Yichuan, are you still lost in the Indian Ocean? Okay. Everyone is okay. It's just a way how it's being written. Okay. Why it's important? I will let you know later. Why it's important to understand this. Yes, class. If you are just a hobbyist, if you are just build something for application based, you no need to know all this. Okay. If you are the developer, you want to create your own programmer, yes, you should know all this. Okay. You won't get all this in details, you know, in the web online. Whereas when you're like ESP 8266, there's so many tons of projects, so many YouTube, you click, you can watch, you can learn it yourself. But these technical things is hard to find. Okay, just for your information. Okay, let's move on. Okay, let's move on. We come back to something that is easy. Okay. Okay, this is this assembly window. Okay, you can click this. Then you come to debugging time. Yes, debugging time. Okay, debugging. So I press this, debug. Okay, okay, debugging time. Okay, now it's hot at the main. So you remember just now, if you put this run, if you run, he won't halt at main. He will run. You keep on running. You have to pause it or stop it or what. Okay. Okay. Let's open up some of the things that you want to test. Okay. Let's play around with all the components. You got something called step over. Step over means that when you come to a function, it will step over. Okay, let's play around with it. A lot of students like to use this. This is a single step. I press single step, single step, single step. While one, you won't step over. Why? Because the switch is 0. All right, not okay. This is called single step. Okay, step into means single step. Okay. Is it okay? I give some time for you to play around first. Single step. If you are done, give me a thumbs up so that I can continue. I can't Kampa find you. My dear, I back to KL lah. Each one, you can find me in Kampa Friday. Friday, I'll go back to Kampa this Friday. Okay, is it okay? I know all of you very tired. It's already more than almost touched 3 hours. Don't you think it's very challenging? Okay, now we open up some of the things. Window. We open the stimulus. Stimulus. Okay. Window. We open the program memory. These are the program memory. These are the one exactly same as the hex code just now. Still remember the disassembly here? Okay, so these are the one inside already download into your program memory. Is it okay or not, my dear? Okay, this is the code. Okay, in hex code. Okay, so this is the code 7F something, but just now all empty in the beginning. So 7F, 7F, 777, 7 all here. You see? Still remember just now, né? Here, start from 7 something something. Okay, it is program memory. Okay. So if those days, if you are hacker, you know hacker, you crack, no, some you play game, I don't know, you play Street Fighter, the blood is 100, you don't know how to play, people hit you few times, you die already, become 0-0. Okay, change here, FF, you understand the location. Okay, so just to make you interesting, so if you want to become a professional hacker, like hack the window, you know, then you can, I don't know, like you hack window, all these things, you can consider download this to play around with it if you're good lah. Okay, and detect it easy. Okay, these two things is very good. If you're good in assembly, you're good at C, you can become very good already. But not Python. Python is you can't do all these things. So that's why you learn assembly code. Okay, so this is assembly code just to trigger some interest. Okay, let's move back. Okay. So okay, 0E. But remember, hacking, cracking is illegal. You go to jail, don't come and blame me. Okay, I say it's illegal. All this thing is illegal, but for fun, for your own, for yourself is okay. Okay, this is program code. Okay, so we come back over here, window. There's so many things here. We got variable. Variable is this as shown on the screen. You can have a watch window. Okay, you can have a watch window. Okay, the watches is on same, you know, like port A, they show all the RA0. Port D we are using, okay, RA0 we are using just now. Okay, is it okay? Okay, so open the window again. There's so many. Where is it? Debugging all the breakpoint. Where is it? Because stopwatch, we open the stopwatch first. Okay. We have three things here. I don't want to go very details. Okay, let's some more thing. You got file register. File register means data memory lah. Data memory, data movement memory. Okay, this is faster. We got program code. We got a data memory. This is data memory. Okay, data memory. Special function register, you know lah, all the special function register that you use. TMR0, it lists out all the special function. The red color one, we use it. Thrice, we use it. Okay, we use it. This is automatically is used when we run the program. Okay, the icon we change 0, 1, 1, 1. Remember that icon? Okay, we change. We let you know which one we mark in red color. It's good for when you come to debugging to check whether it's correct or not. Is it what you want? Okay, my dear. Okay. Okay, what else in target memory? Okay, hardware stack, ID memory. Okay, this is the external EEPROM lah. When you store your temperature, you store your EEPROM, the configuration bit, you see whether it's okay. I just put RA0. I want to say high. Fire means RA0 will be triggered. Then I will exit from this loop. Okay? Just assume you press a switch lah. Don't believe me? You watch the RA0 is 0 ma, 0, 0, 0. I press now, I fire, 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 fire. Press 2 more time lah, fire. Okay. You go back to the watch and a single step, come out. RA0 is 0, 1 already because I fire ma. Okay, I not glass. It's so simple. Now we can monitor lah. Now LED 1 is LED 0. Now I single step. All 5 lor. 5 lah. Now 0, 1, 0, 1, 0, 0, 1 lor. Okay. Now I single step again. Okay. So the delay. Don't tell me if I single step I have to repeat 1,000 times. Like for example, I'm going step into 1,000 times. I'm not going to press 1,000 times, so I can step out. Okay, step out from the loop and single step again. I can check AA lor. AA lor. So again, I come to here. I don't want to go into this loop. I can say step over. Step over. He come back over here lor. Come back over here lor. Repeat the process. Is it okay? So it's very simple. Am I right? Correct. Okay. So now I want to calculate. I put this 1,000 ma. Can I know how long is this delay? You can get the accurate delay time using timer, but normally you put a delay like this, long. But how long? So I can debug it. So I put a breakpoint over here. Okay, and breakpoint over here. Okay, so I reset this. Okay, so then I go to my stopwatch. I clear the screen. When I run until here, it takes me about 16 microseconds. Correct or not? So I clear this. When from here I come out here is the total delay time. Come here. See run. Did I press this now? Press. So it's about 180 milliseconds. Okay, it's 180 milliseconds for this delay. Okay, so once we done this, then you must be very happy, isn't it? So now it's the time to move this to Proteus. I want to simulate using hardware, whether it's really toggle 0055 or AA or not. Okay, so class, is it okay? This is a very simple delay function. Well, explosion. Okay lah, okay lah. No, it's recorded. And what's the time now? It's 7 more minutes. We just finished it, the final things. Okay, no worry. You can watch the recording. We try this again in next week lab. Okay, okay. So now I open my Proteus. Is it open? It's open already. Open already. Okay. File, new project. Very easy. Okay, just I browse to my beloved let's say pre-Portios, select folder. I say the blink default, no, okay, just finish. Things come out. Okay, so I press the P, I select my big 18F4550. Okay, this one I needed. Store inside here. So probably I put one LED is enough. Okay, LED, optoelectronic, which color you want. Okay, like, no, this one, just normal LED. Give a color one, a nice color. Red lah. Okay, you like red, one LED enough lah. And I need a push button. Okay, one push button. Okay, probably a resistor to connect. 330 ohm. Okay, 330. Okay, resistor. I choose one 330. Okay, okay, probably when we need 10K. Okay, resistor. Okay. Like this. Okay, 110K resistor. Okay, done. Then I just drag out my design. Very simple. Okay, just now RA0 connect to the switch mark, correct? Which is my push button. I push my push button here and link it to here. I want to pull up my resistor. 10K, is it 10K? Okay, this is okay, very simple. You see, I can do it 500. Doesn't matter, it's just a number. Okay, just rotate a bit. Okay, change it 10K lor. You want 10K, 10K lor. And then because the simulation, you don't know how many K. Okay, come here and you can click into the power. Okay, done. Okay, this one probably we need a ground. Okay, so RD0. Okay, I just put one LED. Where's my LED? Come back to my component. My LED. Just drag this thing here. Drag this thing here. only. To have a ground. You can try it later, tomorrow during weekend. Okay, almost done. Okay, and then of course here we need to load the COFF file. So you have to locate the COFF file. Where is COFF file? Prelab link. Is it here? COFF file. Open. Okay. So then you go back to the program first, because just now still remember here is high enable. When high, I don't want it to switch on, so I do a bit of changes here in my program. Come back to my program. Okay, I equal to, where is it? The switch equal to 1. I do nothing. Okay, and one more thing you need to alert, because the master clear. Because just now still remember they got one section master clear. Come back over here. I know that I'm going very fast because time is running out. No worry, we will do this, in the second section, in the real lab. This is not a real lab. Okay, let you feel, the difficult. Okay, then we have something called master clear. Master clear is on. So when master clear is on, means you need to do a reset. Okay, reset to high. If you put the off, you no need to do reset. Since it's on, we leave it on. You don't want to change anything. So I stop this, I compile this. Yeah, I should just compile is enough. Okay, so I come back, stop this. I come back to my design here. Okay, so since master clear need to be on, I just keeping my power to on it because it's reset when on it keeping a power to on it. Okay, we may run it. So it's not running. When I press this, it's already running. It's high. Why? How come? It's already running, you see? Why the push button is not working? Should be 1. While 1 do nothing. While 1 do nothing. While 1 do nothing. How come? Okay, so it's already blinking. Okay. Okay. To check, you can debug also. You can debug also. We pause. Okay, the debug screen is coming out from here. Run, single step over, all the register file is all here. Okay, and then it's 5 while switch equal to 1 do nothing. Correct what? While switch equal to is RA 0 1 do nothing. Yeah, 1 do nothing. Okay. Okay, you can have a look lah. Just go around with it. Okay, just play around with it. Okay. Is it compiled? Is the COF file compiled? Wow, switch equal to 1 is high. Do nothing. Pre-lab. Running. Yeah, it's not running. When I press, it's running. When I press, it's running. So there is interrupt here. Okay, it's correct. Okay. I received a lot of message. Must be complained about this pre-lab explosion. All this no bill. Switch equal to 0. No switch equal to 1 because mainly because high when high do nothing when I press low then only he start doing things. You can do a debugging here, like for example, okay, it's okay. Like I press here, I running, so I go to debug the source code. Okay, so it's run. You see, he stopped here. You see the red color? Yeah, the red color pointer here means he stopped here. When I press, let's say I put a breakpoint here. Because I need to pause it. Let's say I put a breakpoint here. Okay, I run back. It won't run until I press. Is it running? Until I press. It's hanging. Run. Press this. Something. It's correct. COF file. Okay. In a run. Press, then he run not blinking. Okay, is it all right? Is it all right? Switch equal to 0. No, switch equal to 1 When 1, I don't want to run. When it's 0, then he run. Explosion. Okay, Gaijin explode already. Okay. Okay. So I think that's all. You can have a private section with me. Okay, if you want to go, you want to ask question, you can ask. Remember, this is just pre-lab.